Hello, for 10.5, this is volume and surface area for cones, and this one is going to be very similar to the volume and surface area of pyramids, except this time the difference is it's going to have a round base. So when you go ahead, if you have to draw a cone, cones have a circular base, so it's going to be easiest if you start by drawing that circle. And the front half of the circle is going to be visible if we were looking at a cone, so that's going to be a solid line. And then the back part is going to be the hidden part, so you're going to do that with a dashed line. Then somewhere above it, you're going to put the point for the vertex, and you're going to connect that vertex one to each side of the cone. And that's the easiest way to draw it. I will have a Kahoot where you can review some of the problems, so if you want to look at that, you can look at the link, and then I will post it on Schoology. Okay, so for these, just like a pyramid, it has a slant height, which is going along the side of the cone, slanted, and then it has the height of the cone, which is that vertical line going straight up and down from the vertex straight down to the base. So the surface area, a lot like the pyramid one, you're going to take the area of the base plus 1/2 the perimeter, but the perimeter of the circle is called the circumference. And then we're going to multiply that by the slant height. So to find the area of a circle, it's pi r squared. That's where we get the first part from. And then pi r gives us the circumference. And then we multiply that by the slant height. So this is the formula that you are going to be using because it gives you what the area of a circle is and the circumference, so you don't have to worry about remembering those. Okay, so for the first one, what is the surface area of the right cone? We're going to start with the formula. Surface area is pi r squared plus pi r l, which is, again, the slant height. They give us the radius is 6, so we can plug that in right away. So we're going to have pi 6 squared plus pi times 6. Then we need the slant height, which again is the distance going slanted on your cone. This one, they do not give us the slant height, so we need to solve for it. The nice thing is they are going to be giving us right triangles. So Pythagorean theorem is going to be our friend when we are looking for our slant height or even our height sometimes. So our slant height is going to be our C value because it's across from that right angle. So we're going to have 6 squared plus 8 squared equals our slant height squared. So if we take 6 squared, that's 36. 8 squared is 64. If we add those together, we are going to get 100 equals our slant height squared. So our slant height is going to be equal to 10. And we can plug that in at the end of our formula. Now, if they ask you to give your answer in terms of pi, remember you are going to type everything but pi into your calculator. So 6 squared is going to be 36 pi. 6 times 10 is 60 pi. And then you would just add those together like terms. You would treat pi the same way you would treat x in an equation. So 60 plus 36 is going to give us 96 pi. So that would be your answer in terms of pi. If they say it's okay to round, you can plug it into your calculator using the pi button. So you would just type 96 pi into your calculator, and it's okay to round your final answer to 1 decimal point. So 301.6 meters squared. If you don't remember, we did go over it, but to get pi on the classroom set of the calculators, you are going to hit the second button and then the exponent key, which we call the caret key. And if you look above that one has the pi button on it. If you don't use the graphing calculators and you just use one of those scientific calculators, that's fine. There's a button on there that's just designated for pi, so you don't even have to hit second, you just hit pi. Okay, so that's how you would find surface area. The next one. This one is a traffic cone can be approximated by a right cone with a radius of 5.7 inches and a height of 18 inches. Find the approximate lateral area. So when we say lateral area, we mean just the side area. So this is my traffic cone over on the side. Kind of looks like a hat. Oh well. But the reason we only want the lateral area is because if you were to pick up a traffic cone that has a circular base like a cone, you'll notice that there's a hole in the bottom. So it's not filled in, it's hollow and there's no base to it. So that's why we just want to find the lateral area or the sides of the surface area. So in your surface area formula, we have pi r squared plus, oh, what was the second part? Pi rl. So if you have this, the first part, that is the area of the base, which means that this would be the lateral area or the sides of it. So what we just need is the lateral area. So for this problem, we're going to skip the area of the base. So we're just going to find the lateral area. So to do that, we just need pi r and then the slant height. So if we look at the information they give us, they said that the radius is 5.7 inches. And the height, so remember height is the distance from the vertex straight down to the base, and that is forming a right angle. That is 18 inches. So we need to figure out what the slant height is before we can find the lateral area. So again, if you look, let me just delete this orange so we can see, we would have a right triangle here. So we can again use Pythagorean theorem to find what our slant height is. A and B are going to be the legs. C has to be the slant height because again, that's across from the right angle. So we would do 18 squared plus 5.7 squared equals C squared. So let me just grab my calculator so we can type this in. 18 squared plus 5.7 squared. So that's going to give us 356.49 equals C squared. And if we were to take the square root of that, it gives us a decimal. So I'm just going to leave it as a square root until we get to our surface area. So 356.49 equals C. And that's our slant height. Once we have all of that, we're just going to plug it into our equation. So pi times our radius of 5.7 times our slant height, which was the square root of 356.49. Now this is where we are going to round. So we can type everything in. Pi times 5.7 times the square root of 356.49. And this is when you can round to 1 decimal point. So we're going to have 338.1 inches approximately for the lateral area. Oh, inches squared. Sorry about that. Right. So this one we didn't need the area of the base, so that is why we did not use the pi r squared. So make sure you're reading the questions carefully. Sometimes with these word problems, you don't want the full surface area. All right. That leaves us with the volume of a cone. Very similar to the volume of a pyramid, it's 1/3 the area of the base times the height. So the base is going to be a circle, and the area of a circle is pi r squared. So that's the only thing that's changing because it's always going to be a circle. The base shape doesn't change for a cone. Okay, so if we use that information, we can find the volume for example 3. 1/3 pi, oh, I always put a 2. 1/3 pi times the radius squared. They give us the radius of 2.2, and they give us the height. So it's okay if it's an oblique cone where it's not standing straight up and down. As long as you have the height, you can still find the volume. And when you multiply 1/3, that's the same as dividing by 3. So if you just take the, let's do 2.2 squared times 4.5. And then we'll take that answer and we're going to divide it by 3. And that's the same as multiplying by 1/3. So that's going to give us 7.26 pi for our volume. So if they, again, say leave in terms of pi, that would be your final answer. If they say to round, you would take that answer and multiply it by pi on your calculator. So this would be the two possible answers. 7.26 pi, or about 22.8 centimeters cubed. Okay. Our next example, originally the pyramid had a height of 144 meters and a volume of 2,226,450 cubic meters. Find the side lengths of the square base. So this is reviewing from our pyramid section. So I think that was 10.3. This one they did say we have a square base, so if you are a visual person, drawing a picture would be really helpful. Okay, so we have our hidden side going back there, our solid side. Oh, that actually would be visible. There we go. And there we go. And perfect. Okay, so we have a square base and then we have our pyramid. And it says that the height was 144 meters, and we know the volume. They want us to find the base. So we know the base is going to have the same side lengths of x. All right. So if you don't remember, the volume formula for a pyramid is 1/3 the area of the base times the height. They gave us the volume, which was this really big number, 2,226,450 cubic meters. 1/3. Now we need to find the area of the base. We don't know the side lengths, but we know it's a square. So we're just going to take the side lengths and multiply them together. So x times x would give us x squared. And they gave us the height, 144. And we need to solve for x. To start, I'm going to multiply 1/3 times 144. And remember, multiplying by 1/3 is the same as dividing by 3. So if we multiply those together, we're going to get 48. So let's just rewrite this. We need to get x squared by itself, so we're going to type in that big number, 2,226,450, and divide that by 48. And that's going to give us 46,384.375. We're not going to round because they gave us an exact answer here, so we're going to write all of the decimal points down, and that's equal to x squared. Then, to find the side length, we need to take the square root on both sides. So we're going to take the square root of our answer, and because it's our final answer, we can round to 1 decimal point. So 215.4 about would be the side length. And now, because this is just a length, it's just going to be in meters, not meters squared, because it's not an area. Okay. The last example, we are going to need to use some trig in this one. They want us to find the volume of the cone. So for volume, it's 1/3 pi r squared times the height. This one, they do not give us our radius, so we have to figure out what that is. The information they give us is that we have a right triangle. Let me draw it off to the side for you. That has an angle of 65 degrees and has a height of 16. We need to find the radius, so we are going to have to use SOHCAHTOA. Doesn't go away. So from the angle they give us, we know the opposite side, and we're looking for the adjacent side. The trig ratio that uses that is going to be tangent. When you set this up, is always tangent of the angle. So we're going to do tangent of 65 equals Opposite over adjacent. So that'd be 16 over r. When you want to get rid of the fraction, you always have to multiply by the denominator. So we're going to multiply both sides by r, and that gives us r tangent of 65 equals 16. Then to figure out what just r is, we're going to divide both sides by the tangent of 65. Once you have that, you can type it into your calculator, and this is not our final answer, so we are going to round to 4 decimal points. So that's going to be 7.4609 about. Now we have everything to find the volume. Volume equals 1/3 pi times our radius, 7.4609, times the height of 16. Now, because we already rounded this number, we're just going to round our final answer instead of leaving it in terms of pi. So I'm going to type pi times 7.4609 times 16. Oops. And then I'm going to take that answer and divide it by 3 to multiply it by 1/3. So our volume is going to be about 125.0 feet cubed. And that is our answer. So sometimes you will use Pythagorean theorem to find the missing parts, and other times you will use trig. Okay, if you have any questions on the notes or the homework, just let me know, and I will get back to you as soon as possible.